5 amazing reasons why astronomy is better done from the ground than in space.
Homeric origins.
When you think about what is out there in the abyss of deep space, whether you are looking out at the planet in our solar system or the most distant galaxies perceptible in the universe, the instrument most people think about using for the best images and data is the Hubble Space Telescope. Issues like clouds, atmospheric distortion, turbulent air, or even pollution are no concern. Images are as sharp as the cameras and optics on board allow, and from its position off-world, it can look in any direction we want it to look. Using it, we have seen wonders the likes of which we have never imagined. Hubble has shown us what the universe truly looks like. And yet, there are things we can do from the ground that are indisputably superior to anything we can do from space. There are images we can create and data we can collect that are simply impossible to do from space. Whether we are using ground-based telescopes, balloon-borne observatories, or even a high-altitude aircraft, there are many good reasons to remain here on Earth. Sure, flying above the atmosphere and receiving the omnidirectional perspective that going to space gives you are definitely victories for the space telescope's aficionados. There is no way adaptive optics or pristine observing sites can compete with an observatory that doesn't have the Earth to contend with. But there are some very compelling reasons to do astronomy on the ground, as there are benefits that you lose the instant you go to space. Here are the top 5 reasons why astronomy is better done on the ground than in space. 1. Space telescope technology is obsolete even before it is launched. In order to launch a space telescope, you need to decide what you are going to try to do with it. Design and build your instruments, integrate them on board the observatory, and then launch it. For a mission like the James Webb Space Telescope, the design of its instrument was complete at the beginning of the decade. An instrument built today would have approximately 7 years of superior technology integrated into it. Servicing a telescope in space is costly, risky, and in some cases, like when your telescope is out of reach of a crew carrying spacecraft, practically impossible. But if your observatory is on the ground, simply pop out the old instrument and pop in a new one, and your old telescope is state-of-the-art once again, to the limit of its optical design. 2. You can build a larger observatory on the ground than you can in space. One can already hear your objection that if you just spent enough money on it, you could launch a big telescope as you wanted. That is true, but only up to a point. Specifically, up to the point that your space-based observatory needs to fit into the rocket's launching. The Hubble Space Telescope is only 2.4 meters in diameter. The largest space telescope ever fly is ESA's Herschel at 3.5 meters, but each folded segment must fit aboard the rocket that will launch it. Even in NASA's dream, the Louvre Space Telescope's concept tops out at 15.1 meters across. Yet, on the ground, there are neither size nor width constraints, and 3 independent meter-class telescopes are being designed and built: the GMTO and the ELT and the TMT. In the radio, we can go even bigger, as facilities like Arecibo and FAST have demonstrated. In astronomy, size matters. 3. You never have to worry about a launch failure. Ever hear of NASA's orbiting carbon observatory design to view how carbon dioxide moves through the atmosphere from space? Probably not, since the satellite failed to separate from the rocket during the first few minutes of launch. The entire rocket and spacecraft assembly crashed into the ocean just 15 minutes after its first takeoff. The rocket that will launch the James Webb Space Telescope, the Ariane 5, had 82 consecutive launch successes before suffering a partial failure just 2 months ago. Many space missions have come to a grim end due to failure during launch, deployment, or orbital insertion. Once you have launched, it is virtually impossible to correct a spacecraft failure once something goes awry. From the ground, that will never occur. 4. Ground-based infrastructure is far superior to anything you have in space. Want to keep your spacecraft cool? Better bring all the coolant you will need for the duration of the mission, and or hope your passive cooling system never gets damaged. Need to shield yourself from the sun? Make sure you are always pointing in the right direction and hope your gyroscope never fails. Have an optical component that degrades, fails, or suffers a fault? In space, you are stuck with what you have got, but on the ground, you can have extravagant maintenance facility on site. A faulty, dirty, or damaged mirror can be swapped out. Infrared telescopes can be cooled indefinitely. Repairs can be made by human hands in real time. New parts and people can be shipped in at a moment of notice. It is a remarkable feat that Hubble has lasted for nearly 30 years, but it is taken multiple servicing missions and some luck to make it so. On the ground, the telescopes that are half a century old are still returning cutting-edge science. There is no contest. 5. On Earth, you can observe from anywhere you want. Once your observatory goes to space, gravity and the laws of motion fix at any given time exactly where that spacecraft is going to be. Plenty of astronomical curiosity can be seen from anywhere, but there are some spectacular events that require you to be in a very specific location at a particular moment in time. Occultations are an extreme example of this, where a distant, small object in the solar system passes in front of a background star, but only for a brief instant in a particular location. Neptune's moon, Triton, and New Horizons' first post-Pluto destination, MU69, both occulted background stars, with Triton doing so regularly. Space telescopes have never been lucky enough to catch this, but thanks to mobile observatories like NASA's SOFIA, we have learned how Triton's atmosphere changes with its season, and we have even discovered a small moon around MU69. Because we don't put all our eggs in the telescope's in-space basket, we can do the unique science that the light arriving at our world enables. As a bonus, the two major advantages of going to space can be effectively equaled from the ground with the right technological innovations. By doing our observatories at very high altitude in locations where the air is still, such as atop Mauna Kea or in the Chilean Andes, we can immediately take a large fraction of atmospheric turbulence out of the equation. The addition of adaptive optics, where a known signal like a bright star or an artificial star created by a laser that reflects of the atmosphere's sodium layer 60 kilometers up exists but appears blurry, can allow us to create the right mirror shape to deblur that image, and hence all other light that comes along with it. Additional improvements such as using multiple guides simultaneously can achieve 99% of what you achieve from space but with tens or even hundreds of times the light's gathering power.
Homeric origins.